Covalent bonds share electrons. In chemical reactions, atoms always try to become stable. They do this by filling or emptying their outermost shells. Both these chlorine atoms need to gain an electron to fill their outermost shell. They achieve this by sharing one electron pair in a covalent bond. Hydrogen atoms have only one electron, so they need one more to fill their first shell. Nitrogen needs 3 electrons to fill its outer shell. If it combines with 3 hydrogen atoms, it will form ammonia. Covalent structures can be divided into groups. Simple molecules or giant molecules. Simple covalent substances. Properties. 1. Very strong covalent bonds formed within small molecules of several atoms. 2. Attraction between these molecules is weak. 3. As a result, these have low melting and boiling points. 4. They do not dissolve in water. 5. They do not conduct electricity because they have no overall charge. 6. Most are gases or liquids at room temperature, for example chlorine, water, oxygen. Giant covalent compounds. Properties. 1. They have no charge, so they do not conduct electricity, except graphite. 2. All atoms are bonded to each other by strong covalent bonds. 3. They have very high melting and boiling points. 4. They are usually insoluble in water. Diamond and graphite are examples of giant covalent compounds. They are both made up of only carbon atoms. Each carbon forms 4 covalent bonds. They form a giant, very rigid covalent structure. The large number of covalent bonds in a diamond mean that it is very hard and has a very high melting point. Each carbon atom forms 3 covalent bonds. This leaves free electrons, allowing graphite to conduct electricity. It is made up of layers which can slide over each other due to weak forces of attraction between the layers. Because of this, graphite can be used as a lubricant.